Jake and his friends throw darts at the dartboard below 1,000 times. Well, actually, I don't have a picture here of the dartboard, but it's not too hard to imagine a dartboard. So let me draw a little dartboard here. You get the general idea. They're throwing darts at a dartboard, and they're going to throw it 1,000 times. And they get a total of 66 bullseyes. So they hit the bullseye 66 times. Based on this data, estimate the probability of Jake and his friends getting a bullseye on this dartboard. So let's think about it. They essentially had 1,000 trials. 1,000 times they tried to hit the dart. They tried to hit the bullseye, and 66 of those times they did. So it looks like a good estimate for the probability of Jake and his friends getting a bullseye is 66 over 1,000. Or another way of writing this is the same thing as 66 thousandths. So you could write this as 0.00, actually no, 0.66. 0.66. This right over here is 6 thousandths. This is 6 hundredths, or this could be viewed as 66 thousandths. And the reason why, you might say, well, why isn't this actually the probability? Why does it say estimate the probability? Why can't I say that the probability is actually 0.066? And the general idea here is maybe they got lucky this time, or maybe they got unlucky. In fact, there's some probability that even if the probability is very low of hitting the bullseye, that they just got super, super, super lucky this time. So you don't know that this is the exact probability of Jake and his friends hitting the dartboard. This is just based on your sample. You've done the experiment 1,000 times, and you got 66 successes. To get a more accurate estimate, you would want to do it 10,000 times or 1,000,000 times. And all of these would really be estimates, because the only way to really know what the probability is to do it as many times as it's possible to do it, but you could obviously do this trial an infinite number of times. Now, there's other ways that you could try to tackle this. You could say, well, maybe it's equally likely to hit every point on the dartboard, and you could do something with area. But if we don't go there, and it's actually, we can't necessarily assume that it's equally likely, they're actually trying to hit the center, then the best way to do it is to estimate it using this sample. When I say sample, they took 1,000 samples of this trial. They could have done 10,000. They could have done 1,000,000. But this right over here is our best estimate of the probability of them hitting the bullseye on this dartboard.